So on this page, we're going to start to take those qualities of amplitude, period, and frequency and look at actual equations to find those qualities. We have two what we call sinusoidal equations here, and sinusoidal equations is just a fancy word for transformations of parent sine or cosine functions. So this function is a transformation of the parent sine function, and this is a transformation of the parent cosine function. So where can we put numbers? We can put numbers in front, which would represent a vertical stretch of compression. I'm going to go out of order. We can put a number at the end, which would do a vertical shift. We can also make changes to x. So in here, I have a horizontal shift. And here, the number in front, I have a horizontal stretch or compression of 1 over b because that's multiplied by the x. So looking at how this impacts midline, amplitude, and max, min, period, frequency, and horizontal shift. So first off, midline, we know is the d value. Amplitude, we know is like a vertical stretch from the last page. And we want it always to be positive, so we're going to take the absolute value, whatever's in front of a. My max, once I have a midline and amplitude, my max is just that midline. We add up a, and then the minimum is the midline. Go down a, so that's what these two formulas represent. Our normal period is 2 pi. Having a horizontal stretch or compression of 1 over b is going to impact that normal period of 2 pi by dividing by b. Frequency, we just have is the reciprocal of the period, so that's just 1 over whatever I get from the period. And then a horizontal shift is c value, we already said, positively left and right. So those are quick connections to transformations. Now we're going to look at an example and see how this works. So this is the sinusoidal equation, this cosine equation. Our midline is our vertical shift, so that would be y equals 9, and there's further explanations here if you want to read. So normal midline is 0, we shifted it up 9. Amplitude has to be positive height, so I'm going to do a positive 5. Max value, we have a midline and we're going up 5. Min, we have a midline and we're going down 5. So this is a 14 and a 4. Period. This is my horizontal, in this case it's a horizontal compression of 1/2. So I'm taking my normal period, and if I'm multiplying by 1/2, that's the same as dividing by 2. So it's kind of like we're putting that 1/2 in with the 2 pi. I just get pi. So we've compressed it by 1/2. So it's kind of shrunk in, and that makes the period go faster. Okay. Frequency, reciprocal of period. And then my horizontal shift, I have pi over 3, and because it's negative, that is to the right. One more small piece of information here. When you see these sinusoidal equations, and you don't see any parentheses in them, such as this one, it's always implied that whatever is multiplied is inside the cosine function, and then if you have a +3 after, that would be a vertical shift. So this equation would be similar to this one. I would have to use parentheses if I wanted the 3 to be inside of the cosine function. So we're going to look at some examples of this on the next page. So this is going to go, I'll go slow on the first couple, but then we're going to go a little faster with this. So these are just our different qualities we find from the equation. So my midline here is 2. My amplitude is 5, value A, absolute value. Max to go up 5, min to go down 5. So we have 7 and -3. My period would normally be 2 pi. But I have a horizontal compression of 1/3, so I need to divide this by 3. So my period is 2 pi over 3. To give some maybe easier to understand number, 2 pi is 360. If I do 360 divided by 3, or 360 times 1/3, right, I would get 120, which is equivalent to 2 pi over 3. So my frequency is 3 over 2 pi. My horizontal shift, there is none. There's nothing inside this parentheses to shift the x. Midline, just y equals 0. There's no vertical shift here. My amplitude is 2. My max value therefore is 2, and my min value is negative 2. My period, 2 pi divided by 1/2. Keep change flip to 2 pi times 2, which is 4 pi. And we know that this represents a horizontal stretch of 2. So my normal period of 2 pi got stretched out to 4 pi. So frequency is 1 over 4 pi, and my horizontal shift again is 9. I would suggest trying the next 4 if you haven't already, and you can come back to check. So this one, midline, y equals 0, amplitude positive 3, always positive, so max and min. There is nothing in front of this theta, so it's just a 1, so this is the normal period of 2 pi, or 2 pi over 1. This is not the horizontal shift of this. So my frequency is 1 over 2 pi, and my horizontal shift is pi to the left because I have a plus. Next one, I don't have parentheses, so I'm going to put it where it belongs. Midline is y equals negative 4, amplitude is 1, so the max is negative 3, and the min is negative 5. My period value, this one is our first one where we have this interesting thing happen. My B value is 2 pi, so that's what I'm dividing by. So my period is actually a rational number. My period is 1. My frequency, if I flipped 1 over, is also 1. And my horizontal shift, this time I have 9. Next one, we have a midline of y equals 0, an amplitude of positive 1, so I go up to 1 and go to negative 1. My period is 2 pi over b, so 2 pi over pi over 6. So I have 2 pi times 6 over pi if I keep change flip. This is, if I multiply across, 12 pi over pi. So this is just a 12. So we have another one where by putting a b value with pi in, we see that the pi goes away when I find the period, and I have a nice number like 12 for the period, which we've seen in some of our problems. Frequency is 1/12, and there is no horizontal shift. Moving over to the next one, I have a midline of 50, an amplitude of 100. So we are going up to 150 and down to negative 50. My period, 2 pi over 4 pi, is 1/2. My frequency, therefore, is 2. And I'm going to take a second to pause on this. This is when we can really understand frequency. Let's say we're talking about seconds. So if the period happens in half a second, that means I get 2 periods or 2 cycles per second. So frequency is kind of like speed. It's just harder to think about when we have a frequency that's weird, like 1 over 2 pi. Horizontal shift is pi over 2. It's negative, so we have to the right.